Hello students, welcome back. In the today's lecture, we'll take up an example of exponential Fourier series. Let's take the numerical. Question is, determine the exponential form of the Fourier series. Given a signal, you are given a signal of the form shown in the figure. Shown in the figure, let me draw it clearly. And let the time represented as 0 here, t by 2, t minus t by 2, and so on. Let's assume the amplitudes of the function. Let's say function is given by f of t and the values are 1, and here it is minus of 1. For this signal, you are to determine the exponential form of Fourier series. This is your question. Now, with this one, let's this is my question. The solution is, let's begin with the solution. As we said in the previous classes, the very first thing that you need to do is to represent the signal mathematically. And you know what this signal is, step number 1. So you can write step 1 is represent the signal mathematically. And you can easily see that the signal ft assumes the value +1 in the range 0 to t by 2 and -1 in the range of t by 2 to t. So you can clearly write as f of t is equal to 0. Sorry, it is 1. It is positive 1. It is positive 1 for t greater than 0 and less than t by 2. Also, the function is equal to -1 in this range, that is for t greater than t by 2 and less than t. So this is what exactly the description of the signal is. Now you know the exponential Fourier series, you need to find out what is Cn bar is equal to. So step number 2 is find Cn bar. We know what Cn bar is equal to. We did the derivation in the previous class. So Cn bar is equal to, you need to integrate over the complete cycle. One cycle is from this time, let's say 0 to time t. So this is your one period. So one cycle. So one cycle is of duration 0 to t. And if you divide this as 0 to t, I can say it is 0 to t by 2 and t by 2 to t. So the standard formula for Cn is, as we already know it, it is 1 by t integral from minus t by 2 to plus t by 2 of f of t e power of minus j n omega t dt. Now in this formula, what we need to do is, as per the limits given here, we need to put the values of the function. So this we can write as equal to 1 by t of from 0 to t by 2. The limit is from 0 to t by 2 of f of t, and f of t in this time is equal to 1. So let me mark it here as a plus 1. This is the value of f of t dot e power of minus j n omega t dt. The function also over a complete cycle, the function also contains holds this value, that is minus 1. So you can write plus 1 by t integral from t by 2 to this time t, and in this time the value is equal to minus 1. So minus of 1 into e power of minus j n omega t and dt. Well, fine. Now you know what is the integral of e power of a. We know it is equal to e power of a upon a. So this we can write as equal to 1 over t, and the integral of this part is equal to e power of minus j n omega t upon minus of j n omega, and the limit going from 0 to t by 2, 0 to t by 2. Similarly, the second part is, I'll take the minus outside in the next step. So this is equal to 1 over t. The integration of this part is equal to, again you know it, e power of minus j n omega t upon minus of j n omega. So this minus I will for time being I will keep it here, so that this minus will get cancelled in the next step, and only the positive sign will remain. And the limit here is t by 2 to t. Now for n not equal to 0, so condition is for n not equal to 0. So I can write this as equal to minus 1 over j n omega t, basis 1 minus e power of minus j n omega t by 2, putting these limits t by 2, and similarly for this one plus 1 over j, and this will come out, minus gets cancelled. So let me cancel it with a different sign so that it is clear to you. So this minus and this gets cancelled. So plus 1 over j n omega t into e power of minus j n omega t. I am putting this value minus e power of minus j n omega, and the lower limit is t by 2. Now in this derivation, if you let, so here if you letting omega is not let, we already know it. That omega is equal to 2 pi by t, or omega t is equal to 2 pi, or omega t is equal to 2 pi. So I can put wherever omega t is equal to 2 pi. So therefore this putting this value here, you will get this as equal to uh, again as you put the values, let me put it, minus 1 over j n and omega t, this will be capital here, and this will be a capital one because we have already put this limit t. And for omega t will be equal to 2 pi. So this will be 2 pi braces 1 minus e power of minus j n. Omega 2 is 2 pi. 2 gets cancelled. So you'll be left with only pi, and plus 1 by j n omega t is equal to 2 pi. I'll put it as 2 pi into braces of e power of minus j n into 2 pi minus e power of minus j n. Omega t is equal to 2 pi. 2 will get cancelled. So you will left with only pi. Now we know that the e power of minus j n omega t, we now know that e power of minus j n omega t, when you write omega t is equal to 2 pi, which is nothing but e power of minus j n 2 pi. And you know what this is equal to? This is equal to 1. And you also know because the value knowing this is equal to cos j omega t minus j sin omega t. If you put those values 2 pi, you'll get this is equal to 1. Similarly, you know that e power of minus j n omega t by 2, when you put omega t, so this value is j n pi is equal to e power of minus j n pi, and this value is equal to minus 1 power of n. So I can put these limits here. For this, you will get this value. For this, you will get, you'll substitute 1 minus e power of j n pi is equal to minus 1 by pi. So putting all values there, so you will get, substituting in let's say equation number, this is my signal 1, and let's say this is equation 2. Substituting in equation 2, what do you get is you get the value of Cn. So substituting there, you will get the value Cn bar as equal to 1 over j n 2 pi. This I'm taking as a whole common, 1 by j 2 pi as a whole common, 1 minus minus of 1 power of n, and this is the value for n not equal to 0. Now if you put the other values of n, so if n is not equal to 0, that means n can be even or n can be odd. So for those cases when n is equal to even, the value the value of Cn, will be equal to 0. And for n when it is odd, the value of bar Cn bar uh, for Cn bar is equal to odd. So what do you observe here is if n is a even value, so let's say 2 for example, so minus 1 power of 2, this will be plus value, and 1 minus 1 will be 0. So for all the even values, this part is equal to 0. So for n, I'll write first for the, we will need to calculate this. And when n is equal to even, your Cn bar will be equal to 0. And when you see, when it is odd 1, so power 1 will be a negative number. 3 minus 1 power of 3 will also be a negative number. So negative gets cancelled. That means plus 1 will be 2, and this will be 2 by j n 2 pi, and this 2 gets cancelled. It is 1 over j n pi. So this means what? K, this means what? K, we can write down. We can therefore write down K C of, if it is 0, then C of 0 for n is equal to 0. C of 0 is equal to 1 over t integral from 0 to t of f t dt is equal to 0. So therefore the exponential series, therefore the exponential series can be written in the form as f of t is equal to 2 over j pi summation of n is equal to minus infinity to plus infinity of 1 by n e power of j n omega t, when n is odd, for n odd values. For n is equal to odd, this will be the formula for this. So therefore, now we know that what this e power of j n t is equal to. You can put that value in the cos and sine. So therefore, the trigonometric Fourier series. So therefore, the trigonometric form of this will become as f of t is equal to summation of n is equal to 1 to infinity of 4 by n pi into sine of omega t. This is for n is equal to odd values, all the n odd values. So therefore, with these values, therefore, you can write down C of n with nothing but square root of a n square plus b n square. So which is nothing but equal to 4 by n pi. 4 by n pi. Now and and the amplitude of the harmonics and the amplitude of the harmonics of the harmonics amplitude of the harmonics can be written as C is equal to the Cn plus C of minus n, and which is nothing but this magnitude will, absolute values will be 2 times of Cn. And you know what the value of Cn is? Cn is equal to this. So multiplying this by 2 will be 2 times of the above value is equal to 2 times of 4 by n pi. So where n is odd values. Now the next one is, now you can plot the line spectra of it, and the line spectra for Cn for different values of n. You know, for this n is odd. Odd will be 1, 3, 5 and so on. So for 0, 1, 3, 5, for n odd. So here for n is equal to the odd values. So 7 and so on. Similarly, on the other side, when you take n is equal to minus 1, all the odd values minus 3, minus 5 and so on. So when you put the value of n here in this equation, then you will get the value as equal to, so this is your function Cn, this is your function. When you put the different values of n here, so what do you get for the first case? When n is equal to 1, so you get the value as equal to 2 by pi. Similarly, then this value will be a diminishing and so on. Similarly, on the other side, it will be the negative of it, a diminishing as the value of n increases. So this will be the line spectra of the given signal. So what did you do in this solution was: one, represent the signal mathematically; two, find out the value of Cn, which is equal to 1 by t. So this is what exactly the signal is, 0 to t of ft dt. So then you find out what the Cn is equal to and put the values of n as not equal to 0. So you have the formula for it, and then you can put n is equal to even or n is equal to odd. So for n is equal to even, so this term, whole term will be equal to 0, and the exponential series will be therefore 1 by 2 by j pi minus lim to plus lim to of 1 by n e bar of j n omega t for n is equal to odd. You can represent this in the trigonometric form, and finally draw the line spectra of this. So well, I hope the idea is clear, that how you represent the signal mathematically and then solve it to get the exponential series of this particular signal. So that's all in this video. Thank you for watching this